To make a CSV file, it's just really simple. You say save as on your Excel file, and then you go down to the drop-down menu, the file format, and just click on CSV, and then push save. That's fine. And then that will give you your CSV file. The reason why I'm focusing on this first is because in order to get data recognized by R, usually it likes to be in a CSV format. So that's why I started with that. The next thing, we're going to jump again. And we're going to go to the basic R Studio. So let me get to my screen and minimize this. And anytime anybody has a question, please interrupt me. So your R Studio basically looks like this if you do not have a section specifically for your already saved code. This right here on your left side is where basically your command line where you'll be typing all your commands. On the right side is your environment. This will have all the format of files that you save for the processing you're going through. And this also gives you history. So if you save your environment and you're like, oh crap, I forgot to like annotate something. What did I do? You could potentially be able to pull it up in the history. I've actually never used the connections portion, so I'm going to ignore that right now. And then the bottom part is your directories that you're in. So the home directory is wherever you have set up your RStudio. And then I personally usually like to go to my desktop to work in. You also have plots that will, once you've plotted your data, it'll pop up right here. All the packages that you have in RStudio and have downloaded will be there, and they are checked with, yes, I have this. Yes, I have the availability for this. Different versions will have different packages. And then there is the help. This is like the best part about RStudio, in my opinion, is the fact that if you've got problems and you're like, oh my goodness, I don't remember what AES and ggplot that Dr. Carson's mentioned. I don't know what this means. It will tell you exactly what this means and what can go in this part of the command and what you need to actually do it. And then I really don't use viewer presentation, so I'm not going to talk about that right now. So I have I gave you guys actual code to work with. This is saved. Let me open up the code. Save. Open up. You can open in your RStudio any recent files that you have saved to in R. So I have all my code always saved because I don't know about you, but I don't like reinventing the wheel if I don't have to. And this is where Dr. Carson's was talking about reproducibility and being able to repeat your code and tweak figures in order to be able to have a plot and then tweak it as needed, as specified by your boss or whatever. To install packages, and you only need to do the install packages once for uh, whatever packages you're installing into your environment. All you need to do is uh, type in um, the command line, and you just type in install packages, and then you specify whatever your packages are. I think it would be very beneficial for you guys if you have RStudio up, if you sit there and play around with this. I'm going to talk, they're recording this, so if you guys say miss something, you will have this for later and you will have the code. So you just type in install packages, and then you add parentheses, and then whatever you're trying to install. Say you're trying to install ggplot, you just click gg, type in ggplot2, and then push enter. I have mine already installed. It's probably really confused right about now. But yeah. Also, you have the option, if you already have the code like I've given you, you can also uh, click on right before the install.packages tidyverse, you can click run, and it'll run through installing that package. You can also, if you want to install or whatever, like I have right here, you can highlight them all and click run again. Um, so once you have your package installed, you need to initiate the package and starting and setting up your environment to analyze or visualize whatever you're trying to do. And so yet again, like I said, for the install.packages, you can just highlight everything. If you have something like I've given you, you can click run on all of that, or you can type it in the command line in, library. And then if you want to use, trying to think of a program that I'm not using right now, heat map too, say you want to do a heat map. You can just type it in into the command and hit enter, and it will start the process running. Sorry, I gotta move something. Okay, so the next portion, and I think this is really important because it will save you pain and annoyance of like in typing in a working directory for every single file you upload. I always set my working directory. And to do this, you just type in set WD, parentheses, and then quotations, and then you type in the path to your directory. And what I mean by a path is this whole portion right here. This is a path. And so that it's basically what I call file inception. So you start off in a location, and if you remember, this is the home directory. But within every file that you click in, that is another directory. And so this is why I set it, because I don't want to have to type this out a million times. So you can either type it in into your command line, you can have it set in your R code and click run that way, or you have the option of setting work directory from your bar menus, and you just click on session and then choose directory, and that will pull up uh, directories and potential places that you want it to go. So now we're going to get to the fun part where you're starting to look at data. And so the first step is actually entering the data. So this part right here at the beginning, this is what you call a variable. And this assigns information to a word or class. And this tells RStudio that if you look at this, you have the data, then you have this symbol, and you can use either this set of symbols or you can use an equal sign. When I'm feeling lazy, I use the equal sign, but I think traditional R coders will say to use this. But you're telling RStudio that data is you're taking a CSV file, it's reading that CSV file, and it's telling you that the header that exists on the CSV file is true. So this has a variable assigned, but it also has what we call a basic data type, a logical or a Boolean truth statement. So you could have either true or false in this, but if you click this, it'll read your CSV file. And if you click in your environment, it'll show you all the information that is within reason. If you have like thousands of things, it's not going to show you on one screen, but it'll show you like the information that is within that CSV file that you want to analyze. So if you decide not to set your working directory, this is also where you would have to type in the directory path to that file. So, and something that's great about RStudio is it also tells you when you've done something wrong. So you can see I accidentally deleted the quote mark. And so it's like, hello, your script is wrong. So then you click on it and then it's right again. But so this is why I like to set the working directory begin, so you don't have to do this step every single time, but that is another option for you if you want to enter your data that way. The next to actually properly do making your box plot is I do a process of where I'm converting the data frame that is in data to a long version. I'm going from wide to long. And how I'm doing this is I'm creating a variable, I have the symbol, and then this is telling RStudio pivot longer. I'm going from the longer version. This is the data frame that I originally started with. So data, I want everything in one column, and then I'm assigning names to group. So I'm telling RStudio that there is populations or groups, in this case, the HODSA and US population, and then values. What are the values? So I'm telling it's relative abundance. And so I click on that and the data, it looks like this. So you can see instead of this, where the HODSA and US population are in separate columns, now it's got the group and it's like HODSA relative abundance, US pop relative abundance. So it's kind of doing like a matching thing that was like in the individual columns. So the next step, and box plots are super simple. I'm going to show you a super simple box plot. This isn't going to be terribly informative. And this goes back to what Lisa was talking about, know your audience, if this is just for you, this probably would work. But if you were presenting this to like the general public, this probably wouldn't be enough information. But I always like to do assign a variable to my plots. And so I have my variable, that symbol, and then ggplot, which is what I'm using to actually develop my image. Data long, so I'm using the long version of my data. This is the aesthetic. So the x-axis should be my groups. So my HODSTA and US population. Y should be reflective of my relative abundance data. And then my coloration or fill should be based on the group. And then I'm using a box plot. And then there's different forms of coloration, but I'm doing a manual assignment because I like to assign my own colors. And so you have that parameter. Oops. And then because I want to assign my color, I then say values and then the equal sign and then C. And C actually represents like a vector, so sequence of data points. And so I'm saying my group HODSTA will have this turquoise color, comma, and then my US population equals purple. And then you'll notice that I have plus signs after every single one of my different parameters for my box plot. If you do not have this, it will literally skip over all your parameters. So you notice like because I clicked run and you saw that it only did this parameter. So always make sure you add the plus sign to make sure you get every single parameter that you specified. I don't need a legend and I don't have a title. So if you run the whole entire thing and then you run your box plot, if you look in the plots, that is what the box plot looks like. Now, this is just, I have I have a lot of different specifications. I like my titles to be a certain way. I don't really like the gray background. I also like my Y numbers and titles to be a certain way. So we're going to go into a more in-depth thing. Are there any questions from anybody? I know I'm running through this like wicked fast, so just let me know if you have any questions. So, okay. The next thing I want to add to my box plot and make sure it's more informative to the audience is one thing that's missing is stats. So when you're looking at a plot in a manuscript or on a presentation, you'll see like stars or letters or whatever that person's jam is. So now I want to add that information. So to do that, I am doing just a stat test. So I'm assigning a variable. I'm using the data long, and then I'm using the Wilcox test based on the relative abundance of each group. So I click to add that. Now I want to go to that more complex box plot. And as you can see, there is a lot more code associated with this box plot. And for each one of you guys, I have put little notes on why these are existing where they're at. I've tried to make this very informative for you guys. Um, so yet again, I have my variable assigned. I'm using ggplot. I'm using the data long version. I have my aesthetics, so I'm assigning my x-axis to group, my y-axis to relative abundance, and I'm filling based on the group. Then I'm adding the genome significance. So I'm adding the comparisons is between my HODSTA population and the US population. And then I have these Boolean statements that I want to map my significance. And basically, I'm adding stars to my box plot. The next is I want to add whiskers because I really like box plots with whiskers. It's a personal preference. If you don't like something, but you want to keep it for later, you can always hashtag it out. So you don't have to do that if you don't want to. But I like whiskers. So this is just saying my box plot, it doesn't have, I'm not doing an outlier shape, but I am adding a whisker box plot style. I'm doing the same scale to fill manual with the HOSDA and US population colors. And then the next step is genome jitter. So if you notice on this original plot, we have these outliers that are sticking up right here, and then they're like right up and down. Well, the genome jitter basically will tell R that you don't want all your dot representatives on the box plot in the same Z stack. You want it like controlled scatter within your box plot. And this is informative for people just wants to see like where your data is represented. And actually in some manuscripts actually require to have dots on your box plot that are representative of all your different samples within that box plot that's represented. So I'm basically saying I want a jitter position, but I only want the width of my jitter to be at 0.1 and the height is at 0. And then I'm saying I want it to be, my dots to be black, the size is 1. And I can't really remember what alpha stands for right now off the top of my head. Do you remember what alpha stands for, Lisa, off the top of your head? Because I can't remember.
In jitter,
Yeah.
uh, I think that might be something with the distance, but
Yeah, and you might be right. So these are all parameters, guys, you can mess with. That's the beauty of ggplot. You can mess around this and get what you like. Um, as I was saying before, I like, hey, Charlie, what's up?
Hi, I think alpha is how much opacity there is.
Okay,
So
thank
if you
you.
do like alpha of zero point 0.5, you're gonna have half opacity.
Okay, thank you.
Yeah.
Yeah, it's something that I've had in there set for so long that I don't even remember. So, and then you can change your backgrounds based on the theme. Um, I have dark on a light background. That's the next part is looking at, do you want a panel border? Do you want what color do you want your X and Y axis titles? What size do you want them? This actually minimizes how much manipulation you do when, like, say, when you're making a figure panel for a manuscript. If you've already got your sizes set, you don't have to worry about it. So I make the extra effort and doing all of this. So like I said, I've got the panel grid because I put a little box around it. There's the X and Y titles. Plain means just plain old text. And then there's italics and then there's bold. Uh, and then you can have actual titles like So like relative abundance or group or whatever. You can have legend position, and if you need a legend, you can set that legend. This graph doesn't require a legend, but you can put right, left, whatever. You can look and if you go to help, it'll give you all the options of the different legend positions. And then you can set the plot title within theme as well. And you can give the size and if you want it in italics or not. And then GG title is actually setting the title of the graph. Now, when you do this, you need to use the quotation marks for it to actually set the title. I don't really set an XLab title, which is like you could wear the HOSDA and US population. You can if you want, but I don't. But if you did, you could just type in here group or whatever your title is. So with all that, again, let me move your guys's, sorry. Okay, get out of my way. Run all, oops, run all of this. And then the next part is actually going to plot the graph, and I'm adding the stats on top of that. So it's got the Wilcox test. I want the P format, so P value, the P equals whatever. And then it's got the position of where I want that P title. And so with that, this is what that figure looks like now. It's a little scrunched, but you can also click on zoom and it will give you a zoomed out version, which let me see if I can share that with you. Yeah. So that is what the zoomed out portion looks like now. As you can see, it's got the boxes around it. It's got the titles on both X and Y axis, and it's got my established colors. As you can see what I'm talking about, the jitter. I have a very narrow window of the jitter, but you can see most of the data points quite clearly for these two populations. I know this is like a wicked fast run through of basic R usage. Is there any questions? You guys will all have the data, you have the files. Theo shared or Mariana shared the box that contains the code. This code is very useful. It doesn't have to just be two groups. Like I have just HOSDA and US population. Say you have more, you would just have to add more colors to this. And so if you added more colors and you had more populations, you would just make sure that you have a comma after the population, and then say it was a population from Ireland, and then equal signs, and then the color, just a color off the top of my head. And there you go. But just make sure that if you do that, it's part of your data frame because it will error out if you don't have that. RStudio is really great about visualizing when you mess up something. So you can see right there, I accidentally deleted that quote. It's giving me error messages, and you can click on that and it just tells you unmatched bracket. So you have to look through all this and you're like, oh, forgot my parentheses. Which It now wants to add 2. Okay. So, does anybody have any questions?
I have two questions really quick.
Yeah.
So when you said you were adding whiskers to your box plot, sorry, can you just explain where those are?
Okay. Yeah. So if you look at this plot right here, the whiskers is these T-shaped parts. Like the standard is just in R is like a straight up and down line, but I really like the T whisker. So that's what the whisker is. And that's all about personal choice, personal preference. I don't know. Lisa, what do you prefer?
I prefer not to have the T.
Yeah.
Yeah.
So yeah, we just all have our own preferences. For me, it's just like I really like it.
Okay, thank you. And then my second question was for the p-value for the Hasda.
Mhm.
I know you said you did the Wilson test for the significance, but how did was that also included to get just the p-value for Hasda, or did you add that?
So let me switch to the other screen. So because this is relative abundance data, you do Wilcox or Mann-Whitney test. And
It's
so,
actually because it's not normally distributed.
yeah,
Yeah, it's not because it's relative abundance.
yeah. So you're making assumptions that it doesn't fit within the bell curve for every single individual. If it was like raw data, you usually use like a standard like Welsh t-test or something like that.
Depending on
But
the data distribution. Sorry.
huh?
Even with raw data, you still sometimes need to use a Wilcox and rank sum. That's not, sorry.
Yeah, no, I know what you mean.
Yeah.
It's just really dependent upon your data. That was a generalized statement. I actually don't do stats on, I don't really use raw data often. So, like for this kind of work, I usually normalize it. So, but here is where I did the analysis test, the stat test right here. And then I added it to the plot right here. So I did the analysis way before I actually added it to the code for the plot. Does that answer your question?
Yes, thank you.